在这个部分呢，我们邀请到阿仁来跟我们讨论 functioning programming in Ruby， 欢迎他。
谢谢。Okay, before I start a public service announcement, so I guess most of you saw the opening talk yesterday from Mr. Lin about the dynamics versus static types. And so I came up with this gem inspired by some of the stuff he showed, so you can try that out. It's already a gem, it's on GitHub. Try it out, see what you think. Okay, so functional programming in Ruby. I have quite a lot to cover, and I realized that I am the only thing separating you from your lunch. So I'll have to keep the pace. This is me. This is me on Twitter, Plexus. I'm from Belgium, but I'm based in Berlin. I help out a lot with the Rails Girls stuff, so I do Rails Girls coaching in Berlin. I'm part of a weekly study group, the Ruby Monsters, that Linda mentioned in Berlin. Also help out with the Rails Girls in Brussels, in Belgium. And the day before our camp, Belgian Ruby conference, I organize a beer tour of some famous Belgian breweries. So it's called Ruby Lambic. If any of that stuff interests you, you can come and talk to me afterwards. This is me in Dongting, in Nantou, in 2007, I think. 所以我第一次来台湾是2003年，我非常喜欢这个国家，所以每隔2-3年我再来，所以我就来说我非常高兴有这个机会在这里报告。Okay, I'll better continue in English for the few that don't understand. Okay, so functional programming. So Ruby is multi-paradigm, but it's mostly object-oriented. And this talk is basically about, okay, what ideas can we take from functional languages and how can we apply them in Ruby? And I'm kind of going to talk about 3 different aspects of this. We're going to talk about values, which I think is really important. I'm going to talk about functions, because obviously it's functional programming for a reason. And then we're going to talk a bit about performance and runtime support. Okay, so values. To talk about values, I first want to talk about variables, because I kind of think that, in a way, variables are the opposite of values. And this might sound counterintuitive, but let me explain what I mean. So a variable, what a variable really is it's a name for a place. Right? So when you refer to a variable, you don't refer to the thing, you refer to a place. And in that place, there can be something, but what's in that place can change over time. That's why it's a variable, because it varies. So say that variable x, and it can be 3, and then a bit later it's 5. And if there's nothing in the place, then we say that it's nil. Now contrast this with values. So when I talk about values, what I mean is that it's an unchangeable fact. Okay? It's a piece of information, a fact about the world. And facts don't change. Different values, different facts can reflect different points in time, but the facts themselves stay valid. So say yesterday it was 27 degrees and today it's 29 degrees. We don't go back and change history to say that yesterday was 29 degrees. No, because that's a different fact. Like yesterday it was actually 27 degrees. So when you deal with pieces of information and you don't ever change them once they exist, those we call values. And for some, well, first of all, why would you want this? Before I go on and talk about more details. So the interesting thing with values is that they are safe to share. So when you have a lot of pieces in your code, or a lot of pieces of data that are actually variables and that can change, then you need to think about, do I need a locking strategy when you do multi-threading, or even when you do single threading, like if multiple objects access the same data, is it all consistent? So you kind of you try to encapsulate objects to kind of be safe, but with values, you can pass them around because nobody can change them, so you're good, it's always safe. They're easy to reason about. Because you don't have to think like, okay, what's the value of this variable in this instance, and how does it reflect to the value of that variable in this instance? They're just what they are. Like a value is the thing itself, so it's much easier to reason about. And because of that, they make really good interfaces. So when you write functions or bigger systems, when the things that are going in and coming out are just plain values, that has a lot of benefits, and I'll talk a little bit more about that when we get to the function part. So in Ruby, we have some things that are values. True, false, nil, there's only one of them, they never change. Numbers, you know, and when you talk about numbers, it's very intuitive. Like when you say, you know, increment 23, 23 itself doesn't change. You just get a different value, 24. Symbols, the main thing that why we have symbols and not strings, because when you refer to foo in one place and to the symbol foo in another place, you're actually referring to the same symbol, and that's what makes lookup so interesting. And so those are immutable. And a couple things in the standard library, like when you have a date or a timestamp, that's not a place to hold a timestamp, that is the actual timestamp. Even if you have different instances that refer to the same time, they're indistinguishable. It doesn't matter which one you're looking at. So this we kind of get, but that's mostly it. For the rest, like Ruby is a super free and liberal language. You know, you can poke into anybody else's namespace, you can redefine stuff, you know, you can even do like nasty stuff like instance variable set or whatever. So in my opinion, the biggest virtue, the biggest thing that a Ruby programmer makes a good Ruby programmer is discipline. So just because you can do all these things doesn't mean that you always should. And knowing when you can and when you shouldn't is a really important part of being a good Ruby programmer. So when you choose to start using values to make things immutable, to have those value semantics, you end up using a lot of freeze. You freeze objects, you freeze all kinds of stuff to make sure that actually nobody changes it. And the interesting thing with values is that when you combine them, when you have values, when you have an array of values, or you have an object that contains values, that composed thing in itself, again, behaves like a value. So people find values very intuitive when you're talking about small things, about numbers, but very big things can also be values. Okay, so a quick example. Suppose that we have a class that represents a single element in HTML. So it has a tag, it has an attribute hash, it has a list of children. So we pass that into the constructor. The tag is a symbol, so it doesn't change, but the other ones we freeze to make sure that they no longer change. And then when we want to update that instance, we don't update the instance itself, but we return a new instance with the updated information, so that each one in itself never changes again, but you get new ones that you can pass around. And there's a lot of gems actually, like value struct, immutable struct, that make this kind of stuff easy. The one that I recommend is Anima combined with Adamantium. So Anima gives you your constructor, to hash function, getters, setters, and then Adamantium automatically freezes your instance variables, and it can deep freeze, it can shallow freeze. And then Anima update gives you this update method to only update specific elements. So that's how you can start making your own classes that are immutable, that are just values. Now, when you're talking about this, you might think like this is horribly inefficient. And this is where persistent data structures come in. And Charles is going to talk about a little bit more about that when he talks about like doing multi-threading stuff in Ruby. But the idea of a persistent data structure is that you get the behavior as if things are just copied over and never changed. So the old version is always still around, but you optimize it so that so when you have a collection, say you have a frozen array, when you want to add an element, you would have to duplicate the array and then add the element. But with persistent collections, it could actually reuse most of that memory so that you only really make one more element in memory. And the easiest example is a linked list. And if you'll indulge my beautiful ASCII art for a second. So when you have a linked list and each one points to the next element, and you add an extra element, the first list is not invalidated. It's still exactly the same, and the second one shares this as its tail, and so they both, they share this piece of memory, but you don't have to know that. Like for you, they're just separate lists. So this is the simplest example. But sort of the holy grail of persistent data structures is the hash array mapped Trie, which is a tree structure that lets you implement things like vectors and sets. And so there's a gem that implements that. There's also Clojure is a language that makes heavy use of this, and their data structures are really optimized for doing all this functional stuff. And so Charlie, again, actually has started wrapping these data structures for using them on JRuby. So all that stuff is out there, and you can play with it. And that's really all I can say in this short time about values. But there's an awesome talk from the author of Clojure, Rich Hickey, The Value of Values, that really goes into detail about what makes values so awesome. Right, so those were values. And so things being immutable is a big feature of functional programming. But of course, the other part are the functions. Okay, so what's typical about functions in functional programming? Well, functions in functional programming are supposed to be pure functions. It means that when you put the same thing in, you get the same thing out. Or in other words, your result, your output value, is completely determined by your input values and by nothing else. So there are no observable side effects. So a function that does input-output, writes to the screen, serves up a network request, is not a pure function. So when you start using values, when things are immutable, you kind of automatically start writing pure functions. And again, just like values have very interesting properties, pure functions have pretty interesting properties as well. So when everything is a value, your whole program just becomes mapping values to other values, and you map values, small values, and with small functions, and you compose functions into bigger functions that map bigger values, and in the end, the whole business logic is kind of mapping values to values. So pure functions have reproducible results. So they're super easy to test because you just make the value, stick it in, see what comes out. They are naturally parallelizable. So when when you need that multi-core we saw about in the earlier talk about transactional memory. So when nowadays you really kind of want to start using those multiple cores, or maybe when you're dealing with bigger data, you want to go across multiple machines. So when your logic are pure functions, you can always just branch that out into multiple processes or threads, and then bring it back together again, because they don't need shared state. They just need those input values. And so they are location independent. So that's again where these values and these pure functions make such nice interfaces. If you have a part of your program that's just simple data, simple values in and out, and you kind of want to optimize that, maybe use a different language for that, turn it into a service. It's very easy, because you just have to pass the value across the boundary and pass the value back. So lots of interesting properties. And the final one is that they can be easily memoized. So memoized specifically means that you cache the results, the return value of a function. And so when you have mutable data, you have to be careful what and when you memoize, because you get the age-old problem of cache expiry. But with a pure function, you can just memoize based on the input arguments, because the output will always be the same. Now, Ruby being hybrid, you can do object-oriented programming, you can do functional programming, and so you kind of get the best of both worlds. And so, like I said, pure functions can't do input-output. And so, a big part of your program, obviously, is stateful, is interacting with the user, interacting with services. So you will kind of need that at some point. But the idea is that actually a lot of your business logic, a lot of the core of what your application does, you can represent in a very functional way, which makes it very clean and easy to reason about. And then when you kind of want to do that stateful stuff, you wrap it, you wrap your functional core of your application with this shell that actually does the imperative stuff. So I have a small example of this. It's almost like it's hard to demonstrate this because you really want to play around with this and get a feel for how that works at scale. But just as a small example, so something that's very typically unpure is when you have a command line tool and you want to parse its arguments. So traditionally, when you say like, okay, when they want the version or the help, you would probably say like, okay, just print a message and kernel.exit and we're done. But then, like, think about if you want to write unit tests for that. Like, how do you unit test a function that calls kernel.exit? Similarly, like, it would often mutate the global argv, all kinds of stuff that we kind of want to avoid. So I rewrote this function to just take an input hash, an input list of arguments and return a hash of kind of what needs to be done. So it's straightforward, it's easy to test, and then we have this wrapper around it that calls this function and does the actual outputting to the screen to standard error, exiting the program if necessary. So this can stay very, very lean and small, whereas your main logic is now like this purely functional, easy to test, easy to memorize function. Now, of course, the final thing that makes functional programming is that there's a lot of playing around with functions, computing functions out of other functions, and building functions at runtime on the fly. And this is something. So in Ruby and in object-oriented programming, the main unit of reuse is an object, is a class. And so you kind of bind your data and your functions, your methods that work on the data together into one unit. And so it promotes some kind of reuse, but on the other hand, like all those methods, if objects do kind of similar stuff, but not quite, you kind of have to duplicate that stuff. Like there's, in a way, that binding together doesn't give the same level, the same granularity of reuse, of just like having simple functions that you can compose into bigger functions to generalize these things. And the thing here is that this is actually an aspect where Ruby is not the most elegant language. So we have everything we need. You have closures, lambdas. You can do stuff with procs. You can get method objects. You can do currying and partial applications. So, I'm going to be a little bit hand wavy about that because it's something I'm exploring that aspect, and I think going forward, like there's definitely interest to maybe make those things a little bit easier and more appealing in Ruby, but the syntax sometimes works a little bit against you. So here's I mentioned in the beginning that I did this experimental type check jump yesterday, and so here's a little piece of the code. So this predicate or. It takes a bunch of functions that return a Boolean, and it turns it into a function that returns a Boolean based on a logical OR of the other functions. So it kind of combines a bunch of functions together. And then when you have the list of the types and it needs to check those, it basically turns it into a list of methods, again, based on other lists of methods. And so here it takes actually a method object. It's this check method, you don't see it here, but it takes 2 arguments. And I have to jump through a few hoops here, but I bind the first argument already, so what I get back is a function that still takes 1 argument, and then build it back up into higher functions. So it's like you can do this stuff, and it becomes more natural over time. But like I said, this is still something that is not that elegant yet in Ruby. One gem, though, that's interesting to play around with is Funkify, which makes Ruby functions or methods a bit more like methods in Haskell, in the sense that when you refer to a method, you can, by its name, just refer to the method itself without immediately calling the method. So you can start combining functions more easily. Okay, and finally, because you're probably thinking like, isn't all this stuff horribly unperformant? Isn't it just better performance to just mutate everything in place? So like I said before, smart persistent data structures help. It's a big part of making this work in the large. Generational garbage collection is a really good thing, because if you really, like, if you go the pure functional route, you end up, creating a lot of objects that then very soon after you throw away, because for every operation you have to create a new object. So you have a lot of young objects in that young generation, and so the fact that Ruby now has at least a partial generational garbage collector is a very good thing. Tail call optimization, can't say too much about it, but it's a technique to optimize especially recursive functions. And so when you don't have mutable state, you can't do loops in a typical increment the index type of way. So you need to use recursion. And so you can get very long call stacks, and around 10,000 call frames, Ruby blows up because it just takes too much memory. And so Ruby has tail call optimization, but it's disabled. You can, if you compile your own Ruby, you can enable it. But it's a contentious issue. They thought about enabling it by default, but it messes up back traces. So it's to see what's going to happen there. And finally, as always about performance, like don't just guess what, actually measure and see what your real needs are before writing this stuff off as being not performant enough. And the important takeaway is that, okay, maybe some of this stuff is less performant, but you're dealing with different semantics. Like having these persistent data structures means that you keep much more information around. So when you have a system that actually needs to help you make decisions, you can do that on a much broader, you still have info about the past that you wouldn't have in a mutable way. So you have different semantics, and it has benefits. So don't compare apples to oranges. It's actually a different thing. So in conclusion, Ruby has everything you need, and you can have the best of both worlds. It takes a little bit of trying, it takes a bit of getting used to, but yeah, the benefits are real. So just try it out next time you have some part of your application that you need to write from scratch, or you're working on a library. Just try to make things immutable. Start freezing stuff and see what that does with your code. You'll have to come up with some new techniques to deal with things, but it's an interesting journey. So start using values and see where it takes you, and on the way you'll figure out like all this functional stuff that you need to know. And finally, I'm really digging into this subject, and I'm writing an ebook about it. So it's still a bit young. It's far from complete, but you can already get a pre-release. The full text is online in HTML, or you can buy the EPUB or PDF, and you'll get all the updates. So that's it. 谢谢你们。
Does anybody have any questions?
I know you're all hungry, but if there's any questions?
I think they are starved to death.
So if there's no questions, you can discuss any topic with Arne offline, so let's take a break.
Oh, can I mention one more thing? After the conference, we're going to go to KTV. 所以如果你们喜欢唱歌，大会以后就来我，找我，谢谢。